students, welcome to this first chapter in chemistry. I know this is a pretty unusual way for us to start the class this year. We should have been sitting in front of each other and studying all this face to face, but given the present circumstances, it is necessary to teach in this online mode. I hope you all remain safe. So the first chapter in chemistry is matter, and we will start with that chapter. But I know that you already have a preliminary idea about this chapter, because matter is one of those areas which you have been studying right from class 6. There are certain general areas in matter with which you are already familiar, like the different states of matter, the intermolecular forces, the intermolecular spaces, and how one state of matter like solid gets converted to another liquid and vice versa. The names for these processes like melting, freezing and so on. These are the things you're already familiar with, so it's basically a revision of the older topics, and along with that there will be a certain new areas like the kinetic theory. Now kinetic theory again you will study both in chemistry as well as in physics. So let us start with the kinetic theory as it is given in chemistry, and then we shall deal with it as it is given in physics. So first of all, what is matter? You know the definition. Matter is anything that has got mass and that occupies space. So in other words, it has got mass and it has a volume, and any object which has mass and volume will also have a density, because density is mass divided by volume. So that is the basic definition of matter. Matter is all around us. Every object, including the pen, the pencils, our human body, everything in the universe, our everyday life objects, they are all made up of matter. Now, what is the constituent of matter? Well, the basic constituent of matter is atom. Atom is the smallest constituent of matter, but nowadays, because of the advances in science, we know that even an atom can be further subdivided into other subatomic particles. An atom can be further subdivided into a nucleus around which the electrons rotate, and the nucleus is constituted of neutrons and protons, and you shall study in higher classes that even these electrons, neutrons, protons, they are again made up of something more fundamental known as the quarks. So as of now, all you need to know that atom is the smallest constituent of matter which is an independent existence, and you better know that an atom, it will have the characteristic of that particular element. So if I am taking an atom of chlorine, it is only up to the atomic level that I get the characteristics of chlorine. If I further subdivide the atom into electrons, protons or neutrons, these are not anymore any characteristic of chlorine. A particular electron and a particular neutron does not carry any kind of characteristic which will tell us decisively whether it is an electron of chlorine or of magnesium or sodium. It is only up to the atomic level, that is an atom, which tells us what element it is of. So in that way, atom is the last stage where we get the identity of the matter. Now, what are the different states of matter? 3 states of matter that you are already familiar with are solid, liquid and gas. These are the 3 states of matter which you have studied in your junior classes. There are 2 other states of matter, the plasma and the Bose-Einstein condensate. What are this? Plasma is basically ionized gas. So gas molecules, they can be neutral, they may not have any net positive or negative charge, but when they do have the charge, that is when the gas molecules are either cations or anions, then the ionized gas is told or named plasma. And the fifth state of matter, Bose-Einstein condensate, which is named after the names of two scientists, Albert Einstein and Satyendranath Bose. And the Bose-Einstein condensate is basically a gas of low density at very low temperature. That is the Bose-Einstein condensate, or the fifth state of matter. And these are the 5 states of matter, but you will study in detail only about the first 3, that is solid, liquid and gas. Okay. Now we shall be studying the kinetic molecular theory. What are the postulates of the kinetic molecular theory? In your book you will find that certain headings are highlighted. These are the headings that I have written down, and all those headings, under them there is an accompanying paragraph which explains what is being implied by the headings. So the first postulate says the composition of matter. Now what does this mean? It basically means that matter is composed of atoms and molecules. There are certain molecules in which there is only one type of atom, for example nitrogen. The N2 molecule has got 2 atoms of nitrogen. So that is a kind of molecule having the same kind of atoms. Again we have molecules of substances like ammonia, NH3, or water, H2O. These are the kind of substances or molecules where there are more than one atoms. So we can have both kind of molecules. And based on how many atoms are there present in a molecule, we can say whether it's a monoatomic, a diatomic or a triatomic molecule and so on. For example, we can take the molecule of water H2. The molecule of water is identical in all aspects. What does that mean? That basically means that if you take a glass of water here in this city and you take a glass of water in some foreign land, the composition H2 will have 2 hydrogen atoms and 1 oxygen atom. It's everywhere. The second postulate says that the movement of molecules and kinetic energy. This basically means that whether the molecules can move about their mean position. Now you know that in solids the intermolecular force is very high, so the molecules, they don't move or they cannot move that fast. So what happens in solids? In solid, the molecules, they remain fixed in their position and they vibrate about their mean position, to and fro motion. In liquids, comparatively the force is weaker. As a result, they can move a substantially greater distance. And in gases, the force is the weakest, and the molecules in a gas can move the greatest distance. They can move anywhere or in any direction that they want, and thus they have the greatest kinetic energy. So the smallest amount of movement means the smallest kinetic energy of molecules, and the greatest amount of movement leads to a greatest kinetic energy of the molecules. Greater the movement, greater the kinetic energy possessed. Then we have got the intermolecular space. The intermolecular space is again one idea you are familiar with. So intermolecular space is the least in solids and it is the greatest in the gases, and in liquids it is somewhat intermediate. It basically means that how much space is there between 2 consecutive molecules. In solids the molecules are tightly packed, so space is very less, but in the gases they are loosely bound, so space is abundant. The fourth postulate is the intermolecular force of attraction. So what does the intermolecular force of attraction imply? Again, if you are familiar with this, in solids the intermolecular force of attraction is the maximum. The molecules, they cannot move much from their mean position because the solid molecules all around any one particular molecule tightly binds to that. It doesn't allow it to move. But in gases, the force of attraction is so weak and the space is so large that the molecules can freely move about. This is one of the properties of gases, diffusion. It can diffuse pretty easily. And in liquids again, it's intermediate. Next, we have got the collision of the molecules. Now, what is the collision of the molecules? The molecules of a substance, they often collide with each other. In solid, since they cannot move much from their mean position, the chances of collision are pretty less. But in gases, they can easily move about their mean position. They can go anywhere they want in the container. So the chances of collision are the highest. So gas molecules collide frequently with each other, and they also collide with the walls of the container. Finally, the movement of the molecules in different states. In solids, the movement is minimum. In gases, the movement is maximum. And in liquids, the movement is intermediate. Coming to intermolecular force of attraction, there is something new that you will be doing this year, and that is adhesion and cohesion. So what is adhesion and cohesion? Well, cohesion is when molecules of the similar kind or of the same substance bind to each other. That is, say 15 H2O molecules all bind to each other, forming an entire substance which is water only. And what is adhesion? Adhesion means when molecules of two or more different kinds bind with each other. For example, if the molecules of water are binding with molecules of glass, that is a case of adhesion. Suppose you take a free surface, and on the free surface there is a water droplet. So this is a water droplet, and all the H2O molecules inside this water droplet, they are closely bound to each other by their intermolecular force of attraction, which is the force of cohesion. This cohesive force holds them together. As a result, the water droplet is bound in one place. It does not spread away to the sides. But if you take a glass container inside which water is placed, then in this area where the water is sticking to the surface of the glass, what happens? On one side are the molecules of glass, and on other side are the molecules of water. And molecules of glass and molecules of water, they are closely bound to each other. So this is adhesion or adhesive force. So adhesion basically means two or more different types of molecules bound to each other. And cohesion basically means the similar type of molecules bound to each other. So now we will do something known as the change of state. Now change of state you have already studied: solid to liquid, liquid to gas, gas to liquid, and so on. But what are the factors on which this change of state depends? It depends on, number one, the intermolecular space. It depends upon the intermolecular force of attraction, and it also depends upon the collision of molecules. And collision of molecules is indirectly related to the kinetic energy. The greater the kinetic energy a molecule has, greater is its chances of collision. Take for example that there is a crowded railway platform and you are trying to move through that platform. Now if you are moving very slowly with a very low speed, you are walking very peacefully, or you are juggling around the different crowds, the chances of collision with the crowd is very less. But if you think I have to go very fast and start to run on that platform, there is a greater chance that you will be colliding with different persons in the crowd. So that is basically the case here as well. So greater your kinetic energy, the molecule's kinetic energy, greater is the chances for you to collide either with other gas molecules or with the walls of the container. Now change of state happens generally. What are the different change of states? One of them is solid to liquid, one is liquid to gas, and then we also have liquid to solid, gas to liquid, and then there is another one, solid to gas and gas to solid. And each of them have names which you already know: conversion, of a solid substance to a liquid substance happens through melting. Conversion of a liquid substance to solid substance happens through freezing. Liquid to gaseous is boiling. Gaseous to liquid is condensation. And when a solid changes to the gaseous state directly, that is known as sublimation. And all of this, they happen at fixed temperatures, which are known as the melting points or the freezing points, and similarly the boiling points or the condensation point for these substances. And you are aware with the definitions of melting, freezing, boiling and condensation as well. But a point worth mentioning here is that the conversion of a liquid to gaseous state can happen in two manners. It can either happen at the boiling point, in which case I would say that it is boiling, or it can happen at any other temperature lower than the boiling point, in which case we call it evaporation. So evaporation is also conversion of a substance in its liquid state to its gaseous state, but since this happens at a temperature other than the boiling point, we call it evaporation.